A car starts at rest at a traffic light. When it starts up, it has a constant acceleration of 2.4 meters per second squared to the east until it reaches a velocity of 15 meters per second to the east. What is the time that it takes for the car to reach 15 meters per second, and what is the distance traveled during this time? So this question has two parts. Let's first solve for the time. So we can write out all the known variables. So the initial velocity is 0 meters per second because they told us that it starts from rest. The final velocity is 15 meters per second to the east. And they also give us the acceleration, which is 2.4 meters per second squared. So now we must find a kinematics equation that includes these three things and that which we can use to solve for the time. And that equation is v equals v naught plus at. So final velocity 15 equals initial velocity 0 plus acceleration 2.4 times the time, which we are finding. So rearranging this equation so that it equals t 15 divided by 2.4, and when we put that into the calculator we get 6.25 seconds as how long it takes for this car to accelerate from rest to 15 meters per second. Now the next thing we must find is the distance that the car travels during this time, and for this I'm going to use the equation delta x equals v naught t plus 1/2 at squared. So delta x equals v naught is 0, time is 6.25 plus 1/2, acceleration is 2.4, time 6.25 squared. So 0 times that is 0 plus 1/2 times 2.4 times 6.25 squared is 46.88. So the delta x is 46.88. This is how far the car travels in 6.25 seconds.